Hello everyone, in today's tutorial we're going to see how can we solve this diode circuit. So here is the question that we are given. So we are going to identify the diode current, and therefore we are going to identify the V out and the diode current. So now how can we solve this kind of problem? So whenever you come across to this, the first thing that you're going to take a look is that you're going to take a look to the diode. The diode, are they on or what? Are they on or off? So if you take a look to these diodes, all they are on, because if you can recall, the terminal positive, which is the 10 voltage, it come across is the voltage distributed to the silicon diode and the gallium arsenide diode, and also we all know that the terminal that it distributed all are positive. So therefore these diodes, they are on. So after identifying the value of this diode, they are on, the next thing that you're going to do is that we are going to use the KVL. This is the upper loop. So you all know that we have a current here as let's call the current I1, and also the current that is passing through here as as I2. So after then, the next thing that I'm going to do, when I use KVL, it comes across here and it will drop here. You all know that also if I use the lower loop like that, also the current will go down. But at the end, if these two current come in here, if these 2 points are coming to this point, I must to have I must to have I1 plus I1 plus I2. This shall now become I1, and therefore this shall now become I2. So let's solve this problem and see. So the next thing that I'm going to do, I have to use the upper loop like this. We all know the value of of the silicon diode, which is the silicon diode, it is 0.7 volt, and the gallium arsenide, which is 1.2. so using the KVL, so there is rising and there is dropping. If you check a look to my last video for the diode circuit, I explained how rising and dropping it is. So I'll start with negative voltage. Already it is positive, but I'm going to put negative and all the rest will be positive. But if I use positive, the rest will be negative. So I have to say plus the value of the diode, which is 0.7, and I have to say plus the 2 kilo ohm. So I have to put the kilo aside, but I will use it. So I have to say 2I1 because I'm dealing with the first loop, the first upper loop. So I have to say plus plus I will have, if I come down here, I will have 2 kilo ohm. So but this 2 kilo ohm, at this point I said I have I1 plus plus I2. So if 2 into into I1 plus I2, what shall I going to get? So if I distribute, I will get 2I1 plus plus 2I plus 2I2. So and also I have to, let me say 2I1 plus 2I2 all equals to 0. So I1 and I1, they are in common, so I have to add them and they will become 4I1. So you have to be writing it down. The next thing that I'm going to do, let me clean this. So if I subtract negative 10 plus 0.7, what shall I going to get? If I subtract this, I will get 9.3, but with negative. So negative 9.3, and therefore I have to say plus. If I say 2I1 plus 2I1, it will now become 4I1, and therefore plus 2I2 all should be equals to 0. So this is equation 1, but before saying this as equation 1, kindly write this down because I1 comes first. So I have to say 4I1 plus plus 2I2, which shall now be equals to, when the negative 9.3 causes a constant, it will now be positive. So I'll have 9.3. So this is the first equation. Please write it down because I don't have enough of space. The next thing that I'm going to do here is that I have to take a look to the lower loop, that I will use the same KVL method. So the next thing that I'm going to do here is that I have to again use 10 voltage, and therefore plus the 2 kilo ohm, which is 2I1. And don't forget, I said, okay, I have to say I2 because I'm dealing with with the low values. Don't forget, I said I will keep the kilo aside, and at the end I will use it. So, and then I have to say plus, I have 2 kilo ohm here, so I have to only use the Q because I'll use the kilo later. I'll use the kilo. So I have I1 and I2. I will say I1 plus plus I2 all should be equals to 0. So minus minus 10 plus 1.2, I will get negative negative 8.8. So I have to say plus, if I distribute this, I'll get 2. If I distribute this bracket, I'll get 2I1 plus plus 2I2. And don't forget, we have 2I2, so they will sum together, and I will end up with 4I2. So I have to say 4I2 plus 2I1 equals 0. The next thing that I'm going to do here, I have I1 first. So 2I1 plus plus 4I2 should now be equals to negative 8.8, should cross the equal sign, and I will get 8.8 as my equation 2. So don't forget to keep down this equation 2. So let me keep down equation 1. Equation 1, if you will recall, 4I1 plus 4I2, which is equals to 9.3 as my equation 1. 9.3. So an equation 2 will now be 2I1 plus 4I2, which is equals to 8.8. So guys, you can use the Cramer's rule, and also you can use the substitution method. So after then, you are going to find I1. If I use the Cramer's rule, I already find the value of delta as as 12, and the delta 1 after putting the output in in the first column, I get 19.6. And for the delta 2, after putting the output at the second column, I get 16.6. So after then, the next thing that you're going to do is that, I hope you write it down. I hope you write the value of the value of this delta and delta 1 and this delta 2. So now we are going to find the current. So to find the value of I1 is the same thing as as delta 1 over the normal delta. So if you divide, you're going to get I1 should now be equals to 1.633. Because of that kilo, so this should now be milliamps. And also for I2 is the same thing as the delta 2 over the delta. So I2 should now give what will be the value of I2? Let me put the value of I2 here. The value of I2 after dividing this, it is equals to 1.383 milliamps. So this is the value of I2, and this is the value of the value of I1. So the next thing that I'm going to do here is that, so as you can see, the current through the first and the second diode, the first diode carries 1.633 milliamps, and the second diode carried 1.38 milliamps. The next thing that I'm going to find is the V out. So how can I find the V out? To find the V out, as you can see, V it is equals to IR. So the next thing that I'm going to do here is that I'll just say V naught it is equals to I1 plus I2 multiplied by this 2 kilo ohm. So this 2 kilo ohm. So as you can see, I1 which is 1.633 milliamps and I2 which is 1.383 milliamps multiplied by 2 kilo. You're going to multiply with the milliamps and what, and also with the kilo. So at the end, V naught it is equals to 6.03403. I'll leave it at 3. So this is my V out. So this is the end of this question. I hope you get it more. Don't forget to subscribe to this YouTube channel. Kindly go to the other video that I did on diode circuit. If this video is more helpful to you, kindly consider subscribing. Press the bell icon so that you'll be notified immediately if I uploaded any content.